All right, geometry. Chapter 7 is on this topic called similarity. So you have congruence, where your two figures are the same size and same shape. All those congruent triangle proofs we did. And now you have similar. Okay, so similarity is a little bit different. All right. So the huge main difference is right here at the top. So for figures to be similar, they will have the same shape. So the triangle will look the same. So if it looks like a right triangle, the other one looks like a right triangle. But the size is going to be different. They will look like miniature versions of each other. You should have a big one and you should have a small one. And that is the difference between similarity and congruence. The sizes are not the same. Now, to write is similar to, you use the squiggle from the top of the congruence symbol, right? So no equal sign, just the tilde or the squiggle. So again, how does a figure have the same shape, but then the size can be different? Well, size is controlled by side length, right? If this side is longer than that side, then this one is a bigger shape than that one. Shape is controlled by angle measure. So notice here, if your two polygons are similar, your corresponding angles will still be congruent. But the corresponding sides are going to be what we call proportional. I cannot stress that enough. When you think of a proportion, I need you to think of the word ratio or fraction. Proportional, apart, right? What portion, right? Portion, proportional, ratio, fraction, all that fun stuff. So here are two right triangles. We are going to say that they are similar. So triangle ABC is similar to triangle XYZ. Notice the correspondence is important, ABC, XYZ. So first off, the corresponding angles will be congruent. So angle A is going to be congruent to angle X. Notice the marking, 1 and 1. Angle B is going to be congruent to angle Y. Notice the right angle markings. And angle C is going to be congruent to angle Z. And again, two markings. So notice I did not use the squiggle, right? Angles are not similar. Your triangles are similar. The angles are congruent. And now the sides are going to be in a proportion. So you can write this proportion like this. You could put AB in a ratio with XY, and that's going to be equal to BC in a ratio with YZ, and that's going to be equal to AC in a ratio with XZ. So each pair of corresponding sides is in a fraction, all set equal. This is what we call an extended proportion because there's 3 ratios. Or you could flip these upside down and you could put XY on top and AB on bottom. You could put YZ on top and BC on bottom. Or you could put XZ on top and AC on bottom. So either of these ratios, these extended proportions, is proper. But just notice that you have to maintain the same triangle on the top and the same triangle on the bottom. You can't mix and match. So I can't have like AB on the top in one fraction and BC on the bottom in the next fraction. No. Okay? And the sides must be corresponding. Now, each of these fractions, each of these ratios themselves is called the scale factor. The scale factor is the ratio of corresponding sides. Okay? So right here, it's the ratio of corresponding sides. So again, if you look here, they used BC and YZ from up here. So they did 20 divided by 8, right? 20 over 8. They simplified by dividing both by 4, and they got 5 halves. Now again, I'm okay with you putting 2.5 because that's what 5 divided by 2 is. I don't care about the decimal versus the fraction. It doesn't matter. But understand that your scale factor can go 2 ways because, as I said here, you can put one triangle on top, one triangle on bottom, or you can flip it around. So they did BC to YZ, 5 to 2, right? 5 to 2. You could also do YZ, and I'll do it up here in red. You could also do YZ to BC, which would be 8 to 20, right? 8 to 20, which would be divide by 4, 2/5. And that could also be written as 0.4. So your scale factors can be two directional. Okay. Now, if I was doing this problem and I listed A, B, C first, I would ask myself, what should the scale factor be going this way? How do I get this big triangle and its side lengths to become the small triangle and these side lengths? Well, to get YZ, what would I have to multiply BC by? Well, I have to make BC smaller, so I'd have to multiply it by the smaller scale factor of 2/5. 2/5 of 20 would come out to be YZ. So this formula right here, using 2/5 as my scale factor, would get me between the big and small triangle. So scale factor is directional, is what I'm getting at. Okay, it's directional. Again, it's splitting hairs. I don't care what you list as a scale factor. Either number is correct. But again, just make sure you're using the correct scale factor when you're trying to find these side lengths, as you'll see in our examples. Okay. So again, similarity, proportional. Again, I'll circle it in red. Proportional sides, proportional sides, proportional sides. All right, the last thing to talk about is a scale drawing. So whenever you talk about scale factor, right, we could do these things called scale drawings. And in a scale drawing, it's just where all the lengths are proportional to the actual lengths, right? So the scale lengths are proportional to the actual lengths. They are proportional by this scale, which is just the scale factor. So again, here are some examples, right? 1 centimeter is 50 kilometers, 1 inch is 100 miles, or 1 inch is 10 feet. And again, it's proportions between the actual dimensions and the scale drawing. So here we have, I think this is called the Golden Gate Bridge in San Francisco. So this is the actual picture down here, and here's your scale drawing with the scale of 1 centimeters equals 200 meters. So again, when you're doing this, you're going to set up a proportion, and a proportion is just two fractions set equal. The first proportion is going to be the scale, 1 centimeter to 200 meters. And I want you to include the units. So then the second fraction is going to be the scale drawing length over the actual length. So this is the length in the scale drawing, and this is going to be the actual length or height, whatever they're doing. So again, you're going to be given one of these, either the scale length and have to find the actual, or either the actual and have to find the scale. And just make sure that your scale length is in centimeters and your actual length is in meters. The units must match up left to right. All right, great. So I got 3 problems and a second video to do involving similarity.